Hi everyone. In this video I am going to give a lecture on module 2, that is equilibrium of forces. So we shall see about the varying forces and the equilibrium conditions used for solving the forces. First we shall see about free body diagram, that is FBD. So I have given a figure. In this you can see a man is jumping over the earth, right? So this is earth. So earth is having the gravitational force. We already knew that it is 9.81 meter per second square, right? This particular person is jumping over the earth. So whatever you throw in the earth, it will reach the earth very fastly, right? You know it, because of the gravitational force. So this particular person is jumping upwards, but his weight is falling in the downward direction. The center of gravity of the person, that is the W, weight of the body, it always acts in the center point of the person's body, right? So whatever may be the structure, like whatever may be the shape of the structure, but all the bodies will be having one CG, that is center of gravity. So weight will be falling with respect to the CG, right? So here you can observe the free body diagram of a man, which shows that the force is acting in the center point from him, right, in the downward direction. But in the earth you can see that the gravitational force, that is in the opposite direction. Okay. So while he is just moving upside, the forces are attracting towards the downside, right? And this is clearly explained with this figure. So the indication of the forces, reactions applied to weight is known as free body diagram. So again I have one more example, right? So you can take a man. This man is standing at particular point, so its weight is will be acting in the downward direction. The weight W may be some 50 to 60 or 70 kgs, right? So his weight is falling in exactly in the vertically in the downward direction, and you can observe some reactions produced at that particular point. That reactions are in the opposite direction, right? So you can observe the weight of the person as well as the reaction produced when he stands at particular point. So the free body diagram of the man standing in the earth, you can see the you can see the F1 is the weight of the man and F2 is the reaction produced. The indication of the self weight, reaction and applied forces in the body is said to be free body diagram, right? So this is applicable only when the man is at rest. So the two forces are in equal and opposite direction, but in the case if we are observing the reactions of a moving body or a moving vehicle, whatever, it will change. The next one is how to find the equilibrium of three forces body. In our earlier presentation, in our earlier lecture videos, we have seen about two-force system derivation, that is parallelogram theorem. But there is a three-force system derivation, that is Lam's theorem. So you can see three forces P, Q and R in different directions, and it is having some angles of alpha, beta and gamma. Okay, but it seems like all the forces are in the concurrent force system. Concurrent means it lies in the same plane, right? So it is not looking like a non-concurrent force system, and you can see each force is having some magnitude and a direction, and it says that in the statement of Lam's theorem states that in the three-force system, or if three concurrent forces are acting on a body, kept it in the equilibrium position, then each force is proportional to the sine of the angle between other two forces. How it is possible means by making this three-force system into a closed triangle. Already we had seen triangle law. So the same triangle law we have to make it for this three-force system. So we can observe that R is a vertical force. Just take it as such. And P seems to be topward force. Just convert it into the same, and Q just place it wherever it wherever the orientation is, and just place the angles of alpha, beta, gamma from wherever it gets originated. And you can see alpha from y axis to this Q force having the angle of alpha, and this R force with the basement it makes beta, and P force makes gamma, right? So make the triangle with respect to the three forces which we have already seen. And finally you will get with respect to the similar, like with respect to the sine proportion, you will get one force divided by sine of angle between other two forces. So P by sine alpha, Q by sine beta, and R by sine alpha. This is applicable only in the place of three force system. Right. So again, just I have highlighted the formula of this Lamis concept. So this explains how the three coplanar forces how acts in the equilibrium. So finally you will get, so in case of F1, F2 and F3, you will get F1 by sine beta, F2 by sine theta, and F3 by sine alpha. Just place it. So you will be getting an equation like this. So now we will move on to the numericals. So first, the numerical one, I have two cables AB and CB tied together at B. Okay. So assume B is having a load of 100 Newton. Right. And it is see, always the wires, cables and ropes will carry tensile force. So this BA and BC will be having tensile force. So you can see three forces, that is one load and two cables. Two cables possess tensile forces. Right. So 100 Newton force and T suffix AB and T suffix BC you can observe in the figure. And in order to find the angle, they have given us the hint of 50 mm distance, 25 mm distance and 200 mm distance. Right. So just make a FBD for this. While making, you will get, just take it as theta 1 in one side and theta 2 in another side and find out this. So for finding theta 1, it is theta is opposite side by, see, tan theta is opposite side by adjacent side. Opposite is 50 mm, adjacent is 50. So you will get 45 degrees for theta 1. And for theta 2 again, if you apply the same formula, you will be getting 200 by 25. So finally theta 2 you will be getting. Just substitute this theta 1 and theta 2 in the figure, and you will be having like three forces, that is T suffix BC, means the tensile force like originated from D point and ends in C point. Right. So it should be named as TBC, and again TBA, right. By using the Lamis concept, we know that force by sine of angle between other two forces. For example, W, one force is W. W divided by sine of, how much this angle means? See, we know that it's fully 180 degree. So 180 minus the 180 minus theta 1 minus theta 2 will give you the angle in the distance between other two forces, or the angle between other two forces, right. So 180 minus theta 1 minus theta 2. Already we have found this theta 1 and theta 2. Okay, it's not a big deal. And the next one is T suffix BC, right. T suffix BC is carrying the it has the opposite angle of theta theta 1 and 90 degrees. So theta 1 plus 90, sine of theta 1 plus 90. Again TAB divided by sine 90 plus sine theta 2, right. Just substitute it. So you will be getting the tensions at TAB and tensions at TBC, right. So by using this Lamis concept, we can easily find the tension in cable AB and cable BC. So I will be continuing with the next numerical in my next video. Thank you all.